Hi, how are you doing today? I'm sorry I got delayed a little because of the other program which I had mentioned yesterday. But anyway, I looked for some time and that webinar didn't happen, and therefore then something else got delayed. So sorry for that. And so I've been talking about mindset for those of you who are seeing it for the first time, and my experience and my experiential learning when it comes to mindset, and whatever I've understood and learned, I want to share with everyone. And that's my passion, and that's my purpose, is what I feel at this moment. Maybe it changes after some years, but at this moment, I feel I need to share my learning, my enlightenment to everyone. So I've been talking about mindset, which is basically the way we perceive reality, the way we think by connecting the dots, the way we decide either by the gut or by assessing the benefits and effort involved, and finally, the way we are acting with conviction and consistency. Perceiving, thinking, deciding, and acting is what mindset is all about, is what I have understood and learned and experienced over little more than 50 years in this planet Earth. I'm trying to share that with everyone. And I've been asking you to do a small exercise, which is to talk to your neighbors, friends, relatives, and colleagues on their perceptions of the current reality of people to people interactions post COVID 19 lockdown, and what you believe or think their perceptions could be. Then try to find out if there is any commonality or differences, and based on that, start a dialogue for establishing a collective mindset. This I've been telling is the first step, the baby step, to really understanding and utilizing the mindset so that the entire humanity could benefit and we can have a better society than what we have today. Today, my focus would be on a very interesting topic. Many a times, people talk about quality, with being very, very important in our life, and especially when it comes to manufacturing nowadays, zero defect is quite what should I say, standard which the industry expects. When a vendor is supplying some components or a supplier is supplying some components, it has to be zero defect. There is no doubt on that. And this zero defect mainly means that whatever parts I got to assemble were totally defect free. Of course, there could be defects somewhere in the line, which needs to be constantly looked into and then further improved. Uh, we have still not reached the situation where it is zero defect the entire supply chain. When I say entire supply chain, starting from mining, when it is a mechanical part, starting from mining, then manufacture of the metal, and from metal to either make a casting uh, or steel or ingot or whatever, and from there roll it down to bars or rods, and from then on to turn it either to turn and make components, or to do a casting, and from the casting do the machining, and from the machining maybe do some other super finishing processes, and after that assemble it, and then put it on the field for the product to function. So this entire supply chain, if we take, we have still not reached a situation where we have achieved zero defect, and that would be the ideal state for which all of us are working today. Therefore, quality is extremely important, and quality delivery is also equally important. So, I want to talk about a couple of experiences in my life which defines the mindset. First, let me start about a recent experience which I had with one of my clients, whom I was consulting about 6 years back. And my job was to see that this company turns around. They had quite a serious problem in terms of quality, in terms of delivery, and the rejections were quite high. So I was called upon to really say that you please see how you can turn it around, and that was my task. So I used to go there maybe once or twice a week because the situation was quite intense. They were supplying to quite a few customers, and the customers were quite pissed off, if I may use the word, with their performance. And there was a very imminent threat that they would be totally stopping this vendor and then switching over to another vendor. However, in that industry, to switch over a vendor will take almost a year because of a lot of tests involved and endurance, etc. Therefore, it was being talked about, but not still really the reality. They would have anyway lost the business in about a year's time. Therefore, they called me. And one evening around 6:30 or 7 in the evening, I was sitting. They had given me a table to sit, and my job was not really doing any activity there. I would basically conduct meetings and facilitate. That's what I'm good at. I would basically get people to think and get people to act. So we had an evening discussion with the team on, I think, the engineering issues where there were some, what should I say, lapses or some challenges in the in the way the manufacturing process was planned. So we were talking about that and trying to redesign the manufacturing process. And I was there in that discussion. And then the discussion had got ended, and I was waiting for another meeting to start. So in the meantime, I was sitting there alone at my desk. They'd given a cabin also, so I was sitting in a cabin, and suddenly the production head came to me. He said, "Sir, I need a help." I said, "What can I do? What can I help you?" Then, as he was trying to explain, the quality head barged in. He said that, "Look, sir, this fellow he's not listening to me. There is a problem." And now I said, "Both of you calm down and explain to me what the problem is." The problem was the following: there was a customer delivery to be done. Somebody had committed, the company had committed, so therefore the commitment had to be held. Delivery was to be done the next day morning at 10 o'clock. That was the shipment time. And we were the previous day at 6 o'clock in the evening, and then 6 or 6:30 it must have been. Then they counted the story. Story was the following. See, in any assembly, okay, now I need to explain a little about manufacturing to those of you who are new to the manufacturing industry. In manufacturing, there is what is called an interference fit. In the interference fit, let us say there are two components to be assembled. Let us say one shaft and one barrel. And this assembly could be either a clearance fit, in which case it moves in freely, like in the case of a piston in a car or a scooter, where it is moving freely, or it could be something where it is an interfer. That means it is basically pushed in to fit there. Once you have fitted it, it can't come out. That's the other type of assembly. There are two types of assemblies which are possible. It depends on the diameter of the barrel and the plunger. If the plunger diameter is slightly higher than the barrel diameter, then when you are pressing in, then it gets pressed in there. This is something used in assembly. There are quite a few of such assemblies in washing machines, in cars, in televisions, and in all components. That kind of an assembly. This is called an interference fit. And the purpose of the interference fit is to hold these two together. They should not come out. Wherever there is a bearing involved, a bush involved, then it's an interference fit, because the outside casing will be made with, let us say, cast iron, and the bearing will be normally made with a soft material, which could be bronze or brass or whatever. So this brass bush is basically pressed into it. It's called a pressing in operation, because you can't really slide it in. The diameter of this is bigger than the diameter of the barrel. Therefore, you can't slide it in easily. You need to push it in, press it in. And when you press it in, this particular component gets elongated. It gets deformed. It gets basically elongated, plastically elongated, and then once it is elongated, it is pushed in, and after that there are pressures there which would hold it in the same position. That is called as a pressing in operation. Now, in the pressing in operation, the key is to ensure that the pressing in force is measured. Today, there are modern technologies available, and it's been there in vogue for almost now 2 decades, I would imagine. But today, it is much more advanced, wherein you are constantly monitoring the pressing in force required for pushing this plunger into the barrel, and what is the speed of change? What is the speed at which this is entering? See, let us say I put in 10 kg of force, then it could possibly enter at some speed. And if I'm putting 50 kgs of load, it can be entering at a different speed. So if the speed is less, then the deformation in the barrel will be elastic. So in metal or in any component, there could either be an elastic deformation or a plastic deformation. When it is an elastic deformation, it's like a rubber band. It expands, but then it basically contracts again to keep it tight. That is the elastic deformation. A plastic deformation is when you try to push in something and it became big. It stays in the same position. So there is no pressure acting on the plunger when it is a plastic deformation. So if you have to achieve a elastic deformation, then the load which you give should be slow and it should be controlled. So therefore, the pressing in load and speed against time is measured, and that needs to follow a specific curve. That is definitely established for each component. So sorry for being a little technical in this live video. I need to explain this background. Only then will everybody understand what I'm talking about. Then these two started explaining to me what the problem was. Problem was the following: they had got the pressing in done. This was done by a vendor, and the vendor had forgotten to monitor the pressing in force, speed, and the time duration which it took. So therefore, there was no curve available to see what is the pressing in load against the time. So when that curve was not available, the quality guy said that since it is not available, I am not sure whether this component will be correct or not, because it's a component which is used in a very critical application. In case the deformation is plastic, then the component will come out. So there is a way of testing it out, which is the press out force, wherein you're trying to pull it out and find out what force it is. That force is not a very reliable test, because it doesn't. It also could mean that the inner component is now become elastic or plastic. Therefore, the test is not very reliable. The most reliable way of doing it is to ensure that it is measured during the assembly itself, which was not done. So the production guy said that, look, we have been supplying this part for a long time, sir. It's not a problem at all. The process is the same. So there should not be any deviation. So if it is, I've been telling him that, look, we will generate the data and give it to him. I said, how are you going to generate the data? Then he said that, look, I'll prepare a table, and then based on the earlier experience, we'll somehow simulate and then generate the data, because the customer wanted to see the data of each part which is assembled. I said it's a critical application. Therefore, customer wanted each part data to be seen. So the production guy explained to me that, and then he said, it's very sure, sir. I'm guaranteeing that. I've been doing it for donkey's years now, and we never had a problem. And the quality guy said that, look, it's not about doing it for donkey's years, and problems always happen when there is overconfidence, and that's where Murphy is most active. I think all of you must have heard of Murphy's laws. Is the most active. So therefore, we should not take the risk. My suggestion is that we either should maybe take a higher sample, and then out of 100, maybe 20, and then check out at least the press out load. Compare that with other earlier lots. In case it is okay, then we will take the risk and then tell the customer that we have missed it out. And if case the customer accepts, and we tell him also what we have done, and then we will send it. The production guy said, if we do that, then the customer will feel that we are not capable and we are incompetent. Therefore, that will not work out. So we want to send it just like that. So the question was to me to give my direction. So I heard them for almost about 15 minutes of explanation. Of course, I could do it in about 4 minutes, because of the possibly third or fourth time that I'm talking about this case in front of public. And then I said, look, I don't have any confusion at all. Where is the confusion there? First of all, your agreement to the customer says that you're going to do the pressing in load 100%. And your agreement with the vendor is that he's going to do 100%. So if you have not done that, it is breach of contract. So it's breach of trust. So there's no question at all. I would, in fact, scrap all the parts. I don't even know what would be the implication, because it's a very critical, extremely critical application. In case something happens, then it could cost us crores of rupees. So I would not really take the risk at all. Scrap the lot and then get the new lot done. So I don't have any doubt at all. Why is this discussion happening at all? And then both of them looked at each other, and then they said, okay, sir. So that is I think now it is clear. We'll have to scrap that and then do a new lot. I don't even go in for checking the press out load, because the press out load check will not give you the correct data at all, correct inference. Now you can tell me that I'm an expert. I'm not an expert in pressing in or anything like that. I'm just an expert in getting people to think and getting people to do the right thing. Now imagine if you have a contract on one side, and the contract says this is what you need to do, and on the other side you got actual reality which is not matching the contract, and then you are trying to do something which is trying to take a deviation. It's not right at all. Now, I take that situation to talk about mindset. So how come the production guy had a mindset that he could even think of that? How can even that thought come into his mind that I can cook up the data or simulate the data in a very sophisticated jargon and then supply the part? Can't exist at all, isn't it? But my dear ladies and gentlemen, even today there are a lot of people who do that. I'll talk about that tomorrow in my video. A lot of people who do that because they have committed to somebody and they have not done the job in a thorough way. Therefore, they try to make it up by showing that they have done it, which in my opinion is absolute nonsense, isn't it? It's breach of trust. So how did you evolve such a mindset? Of course, what happens when you start discussing such topics? The quality guy was good in talking about the topic. And once you discuss the topics, what we did, we again called the entire team and took that as a case study and spoke about that in front of everybody to then get each one's opinion, who was right, who was not right, debated it. We spent about 2 hours. That was one of the first great moments of my life, which brought about a cultural change in that organization. Their scrap levels came down. Today, I'm talking about 6 years since I've been there. Today, and since 6 years, they have been growing at a CAGR, cumulative annual growth rate of about 25% year on year. And that's the magic of mindset. You need to talk to people. You need to talk about that. Put it on the table, discuss. And only then will people form their opinions. And once the opinions are formed, and that opinion is linked with some kind of an emotion, it's definitely a shock. How can such a thing happen? How can such a discussion happen? And then that entire thing stays in your memory, and that memory drives you to behave in a different way. And that's the change of mindset, which I'm talking about. So thanks a lot for watching. I'll again, before I end, request you to do the simple exercise of asking your friends, neighbors, relatives, and colleagues as to what their perceptions of the current reality post-COVID-19 of people-to-people interactions would be, and what you believe their perceptions would be. Try to find the commonalities and differences, start a dialogue to evolve a common collective mindset. Thanks a lot for watching. For those of you in India, have a nice evening. And for those of you outside India, have a great day ahead. See you tomorrow. Thank you. Bye-bye.